All right, everyone. This is Intro to Stats. It's spring 2022, January 26th. And today we are going to start Chapter 2. Chapter 2 is on organizing and presenting data. So let me get my screen shared. We'll start looking at that. So Chapter 2 is organizing and presenting data. So 2.1, in 2.1, we take a look at something called frequency and relative frequency. Versus relative frequency. So just to motivate the topic a little bit, in spring of 2020, it's been a while, I had 3 stats classes. And I asked the students, I said, hey, students. What time of day do you do your best work? And rather than let them give me a variety of options, we talked about this Monday about open questions or closed questions. I did make it an open or a closed question, but I gave several options. I said, is it A, in the morning? Is it B, noon? Around the noon hour? C, afternoon? And I didn't specify like hours that this meant. I didn't say like morning was 6 a.m. to 9 a.m. I just let the student decide for themselves how they interpreted that. D was evening. And E was late night. And after I got all the responses, I won't give you the list of the responses. I summarized them. And in my summary, I found that 25 students said morning was good for them. The noon hour was 30. Afternoon was 20. Evening was 17, and late night was 9. And these are called frequencies. So those are called frequencies. Actually, I'll write it somewhere different. I'm going to write it to the left. Let's go with white. These are called frequencies. All those numbers. And well, what is a frequency? Frequency is the number of times, we want to put it in words. Frequency is the number of times that an outcome appears in the data. I'm going to say or response because oftentimes we do a lot of surveys, so or response in the data. Now, frequencies can be really helpful. These can be really helpful. Can be helpful, but there's something better. And when I say better, I just mean more helpful. And the reasoning is this. My biggest category was 30, right? Is 30 a lot of people? Well, if 30 is a lot of people, if there's only 50 people taking the survey, it's over half. If I have 3,000 people taking the survey, 30 people is just a drop in the bucket. I don't really get a idea of how 30 relates to the rest of the category. So that's where relative frequency comes in. Relative frequency is how often an outcome appears, just like in the other one, in regular frequency, garbage. How often an outcome appears in the data relative to the other results. That's a T. And so the way we determine that is we make each one a fraction or a proportion. Make the results or summary appear as a fraction of the whole. Of the total, that's a better way of saying it, of the total. Get that picture out of the way for a second. So if I add up 25 and 30 and 20 and 17 and 9, I'm going to get 101 as the number, as the total. And so the way we make it appear as a fraction, our relative frequency, what we're going to do is we're going to put the frequency on top over the total. So here, this means this one is 25 over 101. And if I turn that into a decimal, it's 0.2475. And I'm going to do the same thing with each of them. This will be 30 over 101. This is 20 over 101. This is 17 over 101. And finally, 9 over 101. I'm starting to skew downward a little bit, aren't I? If you do these all in a calculator, we get 0.2970. and we get 0.1980, 0.1683. Let me rewrite that last bit. Looks funny. And finally, we get 0.0891. I'm going to pause for a second because I know some of you are writing this down, hopefully. There's a lot to write, so I need to stop for a second. And as a quick reminder to switch from decimals to percents, like 0.1234, what we do is we move the decimal point right twice to make it 12.34, and then we add the percent symbol. And obviously percents to decimals is the other direction. Percent to decimal. If I had 56.78%, I would move it left twice. I'll put a 0 in front. And then I'll drop the percent symbol. So I'm going to do that up here on the morning ones. All these categories up here. Here I've got 24.75%, 29.70%, 19.80 or 19.8%, but I'm going to put the 0. 16.83%. And 8.91%. And so now that 30 means something. The 30 means it's almost 30%. 29.7% over a quarter, almost a third. So now I know it's quite a bit of the population. It's quite a bit of the sample that I. Whereas if it had been 3,000, 30 over 3,000 is 0.01 or just 1%. So it can really change it. And I'll do that down here just as illustration. 30 over 3,000 is 0.01 or 1%. So turning it into a relative frequency makes it a little bit clearer what it means, like how much it really is compared to the rest. Now, that can be a lot of work. Counting them up can be tedious, especially when you're doing it by hand. And thankfully, we have technology to do a great many parts of this. So I'll leave this up here for another minute, let you guys copy it down, and then I'm going to start showing you some stuff in StatCrunch. Anyone need it up longer? You don't have to type it. Please speak. All right. So in StatCrunch, I'm just going to write the commands real quick because it's harder to access this in a second. The way we're going to do it is the combination or the pattern or the path will be stats, tables, and then frequency. And you'll see that in a second. Stats, tables, frequency. So let's take a look at StatCrunch. I'm going to steal the camera. I cannot share screen while the other one is sharing. Interesting. Although I am co-author. Okay, I'll stop sharing. So here we go over here. So StatCrunch, I'm in our homework assignment or homework program, Math 21 Stats, Spring 2022. I'm going to click on StatCrunch. And it gives a couple options. View the data sets from your textbook is rarely helpful. Visiting the StatCrunch website is what we want to do. If you're enrolled in this program, you get StatCrunch for free, so you don't need to do this bottom one. But if you like the program and you do stats a lot later on and your employer doesn't purchase it, it's not that expensive. 20 bucks for a year is pretty cheap for a program. So we have a couple options. Open StatCrunch is a great way to get a blank document. Okay. But I want to show you some of the other things you can do in here. You can make surveys. Like the CSI stats project I put in the orientation module for people to check out. Not very many did, but wasn't required. But this gives me a list of the questions I asked, and I can analyze the data and look at it. We'll do that in a second. So you can look at surveys or make your own. In fact, you can look at what other, notice, let me go back to that. I did my surveys, create surveys there, but you can look at what other surveys people have done. So this is kind of neat. So beverage consumption. I don't know what Math 1530 is. I wish the person had said something like helpful, like statistics or algebra or something. Weekend wings and pet names. People, there's a lot of crazy ones on here. So I've seen ones on superpowers and video games, all sorts of stuff. Other things you can have is groups. We'll be in a group later on for the project. But data sets, you can look at data sets or the data that you've saved for yourself. I'll show you how to save data in a little bit, or eventually. My data, this is the same project I did for fall, and we're going to look at those results. So I'm going to just take a look at that one. So here's my list of results. And notice row 1 has just got the same thing as the gray bar above it. It's not really necessary for the results. A lot of the stuff won't use it. So it's useful for some stuff. I'm going to delete it for now. And to delete a row, you can go click on the rows you want to delete, then go edit, rows, delete. This is not what we're really here to look for, but the reason why I'm getting rid of it is it might interrupt or it adds stuff to our data and we don't want it. So I'll click delete. And now we have all these responses. The first column is just like when they responded compared to everybody else. So it doesn't, these aren't relative to, like, there's no student ID number with this that correlates to a student or anything like that. In fact, some of these responses are not from students. I had the question up on the internet, but there was 182 responses. And let's just look at the age column. I asked how old you were. Simple as that. So let's look at that tables and frequencies thing. So I can do stats, tables, frequency. And I'm gonna, when I get here, I'm gonna click on age. And it's actually already got, notice how frequency and relative frequency are in dark gray right here. They're already both included, which is kind of cool. That's good. They used to have it where it was just one showing up, but now both will show up. And I'm just gonna click compute. Notice I have the option to say output, store, and data table, and it'll take the results and store it in new columns. So if you really want to keep it but you want it to clutter up your data, it can be added to it. I'm not going to do it. I'm just going to click compute. And it says, whoa, lots of unique numeric values for age. Want to turn on binning for this procedure? I'm going to say no for a second to illustrate something, because we're going to look at binning later. There are a lot of responses here. Look at that. I got a 79-year-old. I got 18 and 19-year-olds. I got 24 of each. Frequency is telling me the count for them. So out of the 182 responses, I didn't have to count them up. And it's telling me the relative frequency. If I wanted it as a percent, I could make it into a percent. Just by shifting the decimal. So I'm going to leave that up, and then I'll show you what binning looks like. Maybe I'll move it over to the right, and that way I can get to these easier. I'll do it again. We'll go to stats, we'll go to tables, we'll go to frequency. I'll choose age again. And I'm going to click compute and see if it does the bin option again. It says, whoa, do you want to turn on binning? I'll say yes. So now look what it did. It grouped 10-year-olds to 20-year-olds in one group, 20-year-olds to 30-year-olds in their own group, 30 to 40 in another group, 40 to 50. And so it does every decade. Okay. And it's got 20 in both categories. So where is it including the 20? We'll cover that in a little bit. I'll show you. But it has both frequency and relative frequency. Now, other things that are useful here, I can go and I can change this. I can, if you want to change it without making a whole new table, click on options and click on edit. This will save you a lot of time as you're going through it. I can go, okay, it was doing binning, and it looks like they started the bin at 10. To get the same results they did, I could do start the bin at 10 and make the width 10. And that's not going to change it. The results stay the same. But if I wanted to break it down a little bit more and make it like every 5 years, I could just say start at whatever age I want to start it at and make the width 5. And when I say width is 5, notice what happens. Now the categories go from 10 to 15 and 15 to 20 and 20 to 25. And this might actually be a little more helpful for me because 20 to 30 is quite a range. Like a 29-year-old is in the same category as a 21-year-old when it's 20 to 30. And those are for like, if this is college students, those are two different groups of people. 21 could be a student, or even 20 could be a student that's almost ready to leave college or almost ready to transfer. A 29-year-old student is likely a student that was working and came back to school to decide to change their job or change their career future. That's how I was. I didn't go to college until I was in my late 20s. So maybe breaking it down into bins like this is pretty helpful. And again, just to show, we can do options and edit. And where I did that was at starting doing bins, numerical values, and then width, setting my width to whatever I wanted. Right now, the order number is increasing 10 to 15, 15 to 20, 20 to 25. We can put it in other orders. I could do value descending. Oh, let me edit that again real quick. I turned binning off. There we go. And now it's doing the oldest age group first. And that may not even be what you're looking for. You may want to know which option was the most common and not have to look for it. So another way you could order it is by count descending. And this is pretty handy because notice it tells me the frequencies and they're going down. Now the age groups are out of order, but you can just look over the age group and go, okay, the most common response was 15 to 20-year-olds. The second most common response is 20 to 25-year-olds. That makes sense for a survey that's conducted mostly at a community college. But there are a lot of people that are older than that take classes. So that's frequency and relative frequency. And these age is a numerical column, but check this out. I can do a table on responses that are not numbers, like skin tone or tattoos or body build or weight. You know, I can choose different categories. And so I can choose several of them at once if I want. Like the ones I just said, skin tone, build, or weight. Let's see. Let's go build. And if I want to choose more, if I like clicking the next one just does this. So if you want to get more than one to show up at once, what you can do is hold down the control key and then click the other ones you want, and it makes spaces. And you can do spaces like that. But if you hold down the control key and try to roll the wheel to like scroll down the list, watch what happens when I wheel down. It does zoom. So I don't like that. I'm going to zoom back in. And the way to avoid that is when you want to roll down the list, just let go of the control key, then roll down, and then you hold down the control key again to add another column. So that's one way of getting more than one to show up. And now I can have a bunch on one table. It's got my build, it's got my skin tone, it's got my piercing category and hair length. And if you want to do another one, if you just want them all in order and there's no gaps in what you're doing, let's say I want builder weight and I want all the way down to piercings or all the way down to hair length. I click the first one and then I scroll the wheel down and I can hold down the shift key. So I'm holding down shift key now. I click hair length and it selects all the ones between it. So that's a way of speeding up all of them, but it selects all of them. So you can't skip any that way. So shift key will click all of them between it and control key will help you choose one at a time. Now, this can be handy. Well, it can be quite handy. Notice I didn't have to count up any of this shit, and it counted up a lot of them for me really fast. I'm going to go ahead. Okay, another helpful thing when you're working in StatCrunch, if you close something like these and you want to get them back without redoing it, come over to where, see how it's got a 3 up here? It's telling me that there are 3 results hidden. In the StatCrunch, 3 results hidden. It'll tell me which ones are hidden. The one I had where it was grouped in bins, I like that one. I'm going to choose that one. And I'm going to resort it where it's ascending order. Value ascending. Okay, so that's how ways of organizing and summarizing data. Let's take a look at making graphs for them. Now, we could graph these by hand, and it would be a pain in the ass, but a couple common ones that are easy to do in StatCrunch are the bar plot and the pie chart. And we'll go with both right now. Bar plot, when you have data like I do here, it's all typed in, I'm just going to use that data. I'll say with data. If someone just gave you a list of responses, like they just handed you this over here and didn't tell you each individual response, this is a summary of the data. And we would go with summary, and you would have to type all this, type the value, or tell it where each of the things are in. Usually with data is what you want to do. So I'm going to do bar plot with data. And notice what happens if I do the age. I can do frequency or relative frequency. We'll look at both. Display value above bar is pretty handy. I recommend clicking on it. And we're going to just click compute. And ask me if I want to bin. I'm going to say no at first, just so you can see how crappy it looks if you don't bin. Oh. I want to make it large. So it's telling me all the ages are down here at the bottom. And the numbers at the top of the column are what the frequencies are. So like right here, if it just shows 15 and 20, and it didn't show the 17, I may be like, well, what value is that? Here they tell me. That's why I'm doing display value above bar is pretty handy. So I'm going to close that one. I'm going to make a new bar plot, and I'm going to just do, I'm going to tell it to bin it this time. So graph bar plot with data. And I'm going to go to age. And I'm going to do display value above bar. And when I click compute, it'll ask me about binning, and I'll say yes. And does 10 to 20, 20 to 30, 30 to 40, just like the initial option did. It didn't give me the option to choose the bins of on my own like the table did. So there's pros and cons to each. So this is frequencies. I'd keep that table up. We'll leave age out. We can look at a pie chart. We're going to again do with data. I'll do age again. And if I click just compute right away and I don't turn on binning, look at how lame that pie chart looks. Like that is not a good pie chart. There's just too many wedges, right? And so we can turn on binning there too. I'll redo it. I'll say graph pie chart with data. I'll click age again. And when it asks me this time, I'll say bin it, please. And so there's a couple ways of presenting the data. And it does a pretty decent job. Notice it tells me here the categories. It also shows the frequency right after it. 10 to 20 had 61 responses. And it shows me the relative frequency as a percent this time, not a decimal. Over here, it did decimals. Here it does percents, which is handy. Not only that, it shows what color is, which corresponds to what, and it's got the name of the category inside of it. And if you leave your cursor sitting over it, it pops up the data. So it can be pretty handy. 2.2 is on histograms. And histograms are a lot like bar plots. So I'm going to do that part of StatCrunch right now. I do want to show one other thing for the bar plots. Bar plot with data. If I choose something like build or weight, I've got it. So it doesn't need numbers on it. It can have categories on the bottom, which was qualitative data, right? This data over here was quantitative because it was numerical. This is qualitative because it's category. So I'll put that over here. I'll put that one on top. Oh, let's move it down below. If we want to do histograms, and I haven't really described what they are, it's in the same area. It's graph and it's histogram. So I'm going to do it. We're going to look at how they compare, and then I'll switch to the writing thing and we can write some more stuff out. Notice when I do histogram, it doesn't give me a lot of options. I don't have as many choices as I did before. I can't choose the build. I can't choose hair color. I only get to choose age, shoe size, or height. Those are all the categories. Here's age. Here's shoe size. Here's height. Those are all the categories that have numbers in. So histograms can only be numerical. And we'll leave it at frequency for a second. And I'm going to set the bins to match. Notice it gives me a choice. I get to choose my bins here. But I'm going to set it to look like the one on the left. So let's start at 10 and make it a width of 10. And I'm going to do the value above bar. And we'll look at some of the other stuff in a second. Well, actually later on. Notice a couple things. It's still got the bars. It's still got, they're bars. They're vertical bars, just like the other one. The numbers are on top. But now there's no spaces in them. So they're all kind of touching. And here it says 10 to 20. Here it says 20 to 30. Here it says 30 to 40. Here it's just kind of got like the bars in between it. So I'll point out. If I try to, let's see if I can do multiple things on it. If I try to do age and shoe size on the bar plot, and if I try to do both, what happens? Let's turn on binning. So here it made 2. Let's see if I can get it on the same one. Rows per page, columns per page 2, maybe. I can get a couple on there like that on one page. If I try to do the same thing with histograms, can I choose more than one? Well, let's see what happens. Oh, I can do 2 on the same page. So everything should work the same. Well, that's a terrible thing for a histogram shoe size. So here, the binning that it set at, having width of 10 sucks. 4 to 14 Apparently, there's 3 people with a shoe size bigger than 14. That's a big motherfucking foot right there. That is a big foot. Holy crap. So let's put the other one back up. And we'll bring out the old bar plot that we had that has just data on it for 8. Oh. That's not the one we wanted. Let's just edit this one to match. There you go. So they look sort of the same, but they do different things. 1 second. I have to take this. Where's my Zoom meeting? Oh, let me do it over here. Mute. Just give me 2 more minutes. Okay, I'm really sorry about that. My mom's having an emergency and my wife is taking care of it for me. Okay. So let's switch to the other screen. She's all right. She's been a little bit dramatic, but it's something that needs to be taken care of right away. She's 79, so it's not like she's a spring chicken. All right, so histograms. Well, let's do this. Let's compare bar graphs and histograms. Okay. So, well, first off, what do they have in common? commonalities. Well, they were both rectangles, right? They both had rectangles or bars. They both could show frequency or relative frequency. Oop. Let's just erase that and try again. What the hell? Delayed erase. Frequency, relative frequencies. Okay. And we can take a look at the bar graph. Well, first thing I noticed is the bars didn't touch. I didn't show it, but I'll show you in a little bit. I don't remember the commands. It's on a handout. I'm going to show you where you guys to find a handout, but you can do multiple data sets on the same graph. I had them showing on the same screen, but I didn't really actually show the process of doing it. I was able to do quantities with bar graph, but I was also able to do categories. Or categories. It could be either. I also didn't show it, but there's an option to make the bars go horizontally. And finally, they can go in any order. Like I would have been able to do in fact, we can do it, check it out at the end. I could have done that count descending and then just showed all the bars going down, and it would have put the bars, you just would have had to read the bottom of each thing and see which category was what. Those are options for the bar graph. And if we take a look at the histogram, well, on the histograms, God, the pen seems so narrow. Let's up the point. Histograms, oh, that's better. A little thicker of a pen, right? Bars have to touch. Bars must touch. Oh yeah, I need to change the thickness on all of them. I like that much better. That's much easier to read. We can't do the same or different data sets on the same graph. We have to do separate graphs for separate data sets. Histograms, I was not allowed to choose categories. It's quantitative data only. Histograms, you can't make horizontal bars. It's vertical bars only. And finally, they have to remain in order or be, oops. The x-axis has sequential or in order groupings or bins. On StatCrunch, although we didn't do it, we're going to do it a little bit later. We can plot the mean and median on it really easy. And those are the primary things that we can do. Okay, so I want to talk about something else we saw there, and it was a little bit confusing. Let's talk about how it was doing the bins for the age. So the bins for age. Oh, let me change color. Did anyone need that text up on the screen longer? If you do, let me know and I'll change it. Change it back. I want to change the marker thickness there too. There we go. Okay, so the bins are groupings. It didn't start at 0 to 10, but it started at 10 to 20. I'll do 10 to 20. And then it said 20 to 30. And then it said 30 to 40. Now, when we look at that in like math jargon, like I've got, it makes a real serious question pop up. Which, ooh, that definitely is thicker. Let's go big on that one. Let's do that one. Where do I put the 20? I don't like the rainbow text. It's not working for me. Where do I put the 20? So this is what happens. What this 10 to 20 really means is that, like, if X is our value, let me change the thickness here too. If X is our value, this 10 to 20 means that 10 is included. So 10 is less than or equal to X. And then it's less than 20. So it doesn't include the 20. The 20 goes in the next group. The 20 would appear in the second grouping. And this one will go up to 30, but not include 30. This one goes from 30 to 40, includes the 30, but not the 40. Okay, in interval notation, if this is familiar to you at all, and it shows up on the graphs, and I'll show it to you when I go back to StatCrunch. This is 10 to 20, and they put a parenthesis. Ooh, I need to change the thickness. I'll just rewrite that part. So, damn it. So they do a thick bracket, they do 10, they do 20, they do parentheses. The bracket means include this number. The parentheses means go up to this number, but don't include the actual number. And so a better way to really look at that is where rather than saying 10 to 20, I could actually just write this as in a way that makes more sense. It's like 10 to 19.99. That makes it a little clearer, right? Unfortunately, putting 19.99 on the pictures, the histogram, makes it look kind of ugly. So it's not that helpful to do it that way. But it's better to see it that way. That's what these two things mean. So the 20 goes there, but we use parentheses for the 30. And these will, I want you to know what these mean because you'll see them on the graphs. And that way you know what you're looking at. So 10 to 19 or 1999. Then we would have 20 to or 20.00 to 29.99, 30.00 to 39.99, and so on and so forth. So StatCrunch shows you that this. That's what StatCrunch says. I use in my notes, SC is an abbreviation for StatCrunch. Get used to that now. And we noticed that the bins were pretty useful. Let me pause and make sure everyone's caught up. That doesn't even look like the word plot right there. It looked like plot. It was supposed to be put. Okay. So a couple things to note. If you need that up longer, please say something verbally. The bins classes are pretty handy. When you have too many different responses. Or outcomes, different outcomes. But it only works on numerical data. I don't think you can bin names and stuff like that. I'll have to try that. I wonder if you can, if you just let everybody put in a name, and I might be talking out my ass. You might be able to bin numeric or categorical data, but I don't think so. I'm going to write those numbers we had a second ago again real quick, the way they show up in StatCrunch. I'm going to say 10 to 20, 20 to 30, 30 to 40. these numbers on the left are called the lower class limits. Class is another name for bin. These are called the upper class limits. And I'm going to rewrite the 10 to 1999 again for a second to illustrate an idea. And that idea is this. Finding the starting, like if you're going to make bins or want to decide how you're going to make bins. Gotta change the thickness on that one too. There we go. Starting bin or starting point would just be the 10. And it shows up in both of them. And the way you do the width, and it works on all of them, is subtract consecutive lower limits. And notice if I go do like, these are the lower limits. If I do consecutive means the next one, the very next one. So if I do 20 minus 10, I get 10. If I do 30 minus 20, I get 10. So this is the width. And no matter which setup you've got going on, it's easy to see how to determine that. I'm going to tell you right now, this is a big, big warning. Homework problems will try to trick you. Or really test you on this. And what I mean by that is they will give you that 10 to 1999 and the 20 to 29.99. Because they know it's a common mistake to want to do this number minus that number. And if I do 1999 minus 10, even if I do it in a calculator, this is going to be 999, and that is not the width. So be warned, they will try to trick you. Other information on bins? Am I good to roll up? Is everyone ready? I'll take silence as a yes.
Yeah.
Okay. Sometimes like how to choose a bin. So you have a couple options. The primary choice you should go with is choose one that fits the category, the data set. And what I mean by that is, what if the bins were on units of college completed? And they gave me 0 to 60. If you're in a STEM field, you tend to have a lot more than 60 when you leave community college, unless you happen to like transfer in at calculus level from high school, but a lot of students don't. So full-time, like if you want financial aid, full-time would be 12 units. So we could go 0 to 12, 12 to 24, 24 to 36. That's full-time, but how many students just take 12? It means it's going to take longer than 2 years to complete. A lot of students do option B, where they try to take 15 units or more. So maybe doing 0 to 15, and then 15 to 30, 30 to 45. So 15 units. Okay. Another popular option for choosing bins, and it's not an art. Well, it's an art. You can't just, it's hard to give you like an algorithm or a pattern to do. Pick bins that show the shape of the graph. And I think I'm getting a little bit ahead of myself, but I'm going to do it anyways, because we're talking about bins. I'm going to show you a couple kinds of graphs. If the data is like this, I'll do a histogram. And it kind of like, it has this curve go over it. Where it's kind of humped in the middle, this is called bell-shaped, because it looks like a bell. Or standard shape, standard normal shape, or just normal shape. It goes by a few names. You'll see why the later ones when we get later in the semester. But it's definitely bell-shaped. That's the most common one. It could go like this, where it's got a hump, but it's kind of like on the right side, and then there's a whole bunch of like little bars to the left. And so if I do the curve there, if I make the curve darker, make it pink. This one feels backwards to me the way they named it, but this is how they've named it. If this is the center, these sides are called tails. This is the left tail, and this is the right tail. If the left tail is a lot longer than the right tail, this is called skewed left. And we have the other option where there's a whole lot of bars going to the right. And if we put a little curve going over the top, the tail is now longer on the right. And this one's called skewed right. To me, it feels backwards. I always want to call the skew where the hump is. Like on this bottom one, the hump's on the left, so I want to call it skewed left. But that's not correct. It's the other, it's where the tail is longer. And the reason why is that these, when they're far away from the center, values that are far away from the center can drastically affect the mean, but we haven't covered the mean yet. That's going to be the next chapter. I think it's in chapter 3. I don't think we do it in chapter 2. And we'll go over what types of data like meet in each of those. But picking bins can, if it reveals the shape, it can be helpful, because we'll cover more about that later. But if you're good with that, I'm going to go back to StatCrunch and take a little bit more look at some of the stuff and show you where to find a good document that you'll like. Anyone ready for me to, or is anyone for me not ready for me to change screens? I will take your silence as I can do it. So this age one's pretty handy. Let's tinker around with the ages. And I'll do it with this histogram one. So it starts at 10. Let's go with the width of 5. Let's see what it looks like. And maybe if I go down to 4 or 3. This looks like there's a bunch of high values on the left, but then there's stuff over here on the right. This would be a skewed right graph. And again, this stuff isn't in the homework in chapter 2, but I'm just talking about now as to why we look at this stuff. Let's change this back to something that makes it prettier, though, not too many categories, is the 5. And I want to show you, it'll pop up. We'll do that, show the mean and the median. Now, we haven't talked about what they are, but let's look at what those options were. The green is the mean. The mean's there. You might know what the mean is if you've learned it previously, and the median as well. But if we put our cursors over it, it will tell us what they are, which is kind of nice. If I do the same thing with the height graph, and I don't know how I want to bin it. So I'm just going to tell it to do the optional height binning. So some people put things like their height, they gave me feet and inches, and other people gave me inches. So maybe let's edit this. They look like they've got a width of 20. So I'm going to ignore all the heights that are low. I don't want these low heights because I don't want to include the 5-foot people that are doing it. Let's just include people that are doing it in inches. So I'll say we'll start at 20. Well, maybe let's start at 40 because there's a big gap there. Maybe do every 10. I told it to not, did I not tell it that? It didn't do the start at 40. Rude. I could do width of 5. Let's go down to width of 3. A width of 1 would be not bending at all. And the reason I wanted to show you that is notice over here on the right, there's values on the left that are low, but in the center, it kind of goes up in a mound. This is closer to a bell-shaped one. If these values over here were, like most people are between 5 and 6 feet tall, if they had done theirs in inches, their data would have been right here in the middle as well. And you would have seen a bigger spike in the middle and it would have shown up better. Does shoe size do the same thing? Let's take a look. We'll turn off bending there. So this one's got a nice little bell curve. So that's what we can look at there. And let's see what mean and median look like here. I know we haven't talked about it yet, but green is mean. And notice on the bell curve, the green and the red are pretty close. This is pretty common. When it's a bell curve, the green and red are pretty close. The mean and median are pretty similar to each other. 9.13 versus 9. And when it's skewed, they're far apart. Again, the homework's not on that now, but I think it's good to introduce it now while we're looking at the graphs, because the topics will come up repeatedly later on about skewing and shape. Let's see if there's anything else I want to include on this. See if they do the overlay. Oh, you can show an overlay distribution and see if it follows a normal distribution. I'm going to leave that as optional. We haven't covered mean and standard deviation yet. I'll just tell it to do it. And notice it puts the like the bell-shaped distribution on there. So it shows it. If I try to do that on age, and I do an optional or do the normal distribution, it puts one there, but it doesn't look like it fits as well, does it? And that's another indication of it being skewed. Like, yeah, this goes above the center, but like a lot of it lines up pretty well. Here, this goes way above the center. This is twice the height. The center is like at a height of 30 here. This is going up to 60. Here it's going up to like 35 and it's only 43. It's not that much taller. So that's a difference between like bell curve and skewed graphs. That's it for today. That's 2.1 and 2.2. We'll be covering some more on Monday. I think is Monday. I know we got another holiday coming up eventually. Oh, that's what else I wanted to show you. Let's go over to our course. I want to show you where you can get some information. I've got 3. Notice that 3. 1, 2, 3. If you go into files, and you go, I think it's in useful handouts. I'm going to double check it. Let's just take a look. And we want stats. StatCrunch Tech Help right here. Look at this bad boy right here. So if we click on this, if you print it, it's like 15 pages tops. Section 2.1, organizing qualitative data. Notice it's what I told you earlier, do stats, tables, frequency. It tells you that right there. It's telling you how to do bar graphs from summarized data, which we didn't have, but it also says how to do bar graphs from raw data, which we did have. And it even gives you like tips on what to do. Click on the column name that we wanted to summarize. I did that. We chose age. Leave the grouping option alone. We did that. You can label the stuff better. It also says how to do side-by-side bar graphs from summarized data. Unfortunately, we didn't have any summarized data there. So can't do the side-by-side bar graphs, but that's where you got two bars on the same graph. So like if you're looking at summarized data and it's grouped between men and women, you can see their shapes and have different colors for like men versus different colors for women. And if your grouping has more categories than men and women, it would do that as well. I just use that because that's the common one in a lot of graphs. And we did 2.2. It tells you how to do the frequency, popular displays. It's again back to stats, tables, frequency, but it also tells you discuss bins, how to do binning, how to do histograms. Stem and leaf plots, I don't ever see anyone ever using them. Later on, we'll talk about dot plots. They can be fun, but they're not that difficult to use either. In fact, let's go look at a dot plot real quick in StatCrunch, just so you can see it. So let's do a graph and a dot plot. And we'll go off of age. It kind of explains itself when you do it. Point size just says how big do you want your dots to be. I'm going to choose big dots so they appear better, but that might be too big. We'll find out. Yeah, those are kind of big. Make them a little bit smaller. Ah, hell, I liked it better with the 5. Let's go big. Big dots, there we go. So notice it's got grouping similar. It's got every 10. And here, apparently, every dot represents up to 2 values per dot. So it's kind of like makes its own bars, but it uses dots instead of like an actual bar. And it tells you what age it's looking at. This is age 26, which is row 45 plus 1 more. Tells you where the first occurrence is. So it's going through and it plots dots. Like, are they in order? This is row 152. The next, that one's row 148. It's telling you where you can find these dots at in this data table. So it's another way of looking at it. It's actually handy when you've got a bunch of people making the table together. Like they all have their own data and they go up and put their dots. And then like if we had 3 groups in here, group A puts their dots, then group B puts their dots on top of group A's dots. And then group C puts their dots on top of A and B. Then it makes it kind of really handy to, you get the bar graph effect without having to collect all the data first. Other than that, that's about it. Back to the files. Remember where you can find that. I'll show it again. We're in the file section. You click on useful handouts. Click on stats, StatCrunch Tech Help. And you'll find it's organized by chapter and section. So like if you have this, you'll see what we're doing soon. We just did 2.2. We'll be looking, oh, we're not doing polygons. We'll look at the scatter plot. I'm not doing ogives. Ugh. Measures of central tendency, that's the next big category. And that's where we start talking about mean and median and mode and stuff like that. And so it'll tell you how to do stuff. Like the next section looks like we're doing a lot of stats, then summary stats, then columns. And if I look over here, stats, summary stats, columns, and I can just follow the directions they give. Awesome. All right, that's it for today. Thank you. You guys have a good day too. I'm glad you guys got some value out of it.
See you
Thank you,
later.
Mr. Jones.
See ya.
See ya, Mr. Jones.
See ya, Ariel, Jorge, Randy, Gabe.
Bye.
Ladies.